Obtain the binomial expansion of 2 minus x multiplied with 1 plus half x to the power of 8 in ascending powers of x as far as the term in x cubed. Use your result to estimate the value of 1.9 multiplied with 1.05 to the power of 8. So let's start looking at this problem by trying to expand the second term, which is 1 plus half x to the power of 8. So to expand this, let's look back at binomial theorem, which says that when you have this form of expression, is 1 plus b to the power of n, then the expansion can be written into this form here, where this column of n r is equals to n multiplied by n minus 1, n minus 2, all the way down to the term just right before r, which is n minus r plus 1. Alright, so let's try to expand this. So this is pretty straightforward. 1 plus, okay, so this is n is equals to 8, and for the first term r is equals to 1, and then multiplied with b, and in this case here b is this term here, x over 2, right? And then the second term 8, 2, and the entire b put to a square, and then the third term in terms of the order of x would be this one here to the power of 3 and plus the rest. Well, I mean, well, since the question just asks us to, expand as far as the term in x cubed, so anything after that, we are not really interested to know. Alright, so this is just equals to 1 plus 4x plus 7x squared and plus 7x cubed. I mean, you can make use of this formula here, and I'm pretty sure that you're going to end up with this result here, and of course plus something else. Alright, so let's look at the entire term together. So when this is multiplied with 2 minus x, then what we get is basically 2 minus x multiplied by this term here, which is 1 plus 4x plus 7x squared plus 7x cubed plus the rest. Alright, so we just multiply it term by term, and then we get to this point here where we have 2 minus x plus 8x minus 4x squared. I mean, I'm just multiplying term by term. So, and I get this. This is 7 multiplied by 2, you get 14, and minus 7x cubed plus 14x cubed. And in fact, we can do this very fast if we want to, and plus the rest. Alright, so since we are just interested in the term up to x cubed, so this term here is going to be omitted in our next line of the expression. So let's try to simplify the entire term, and this is what we get: plus 10x squared and plus 7x cubed and plus the rest. Okay, and now we have answered the part 1 of the questions, and let's look at the second part. So, and then we need to make use of our result to estimate the value of 1.9 times 1.05 to the power of 8. So we actually have to work out the relationship of this 1.9 times 1.05 to this 2 minus x multiplied by 1 plus half x to the power of 8. So, and we can actually get, try to substitute a value to the x so that we get back at the exactly the right expression. So let's assume that x is equals to 0.1. So if x is equals to 0.1, then what happens is that if we substitute this x into this equation here, then we get 2 minus 0.1 multiplied with this 1 plus half multiplied with 0.1 to the power of 8. So this is equals to 1.9 times 1 plus 0.1 divided by 2 is 0.05. So this is 1.05 to the power of 8. And this is exactly the same as what we get here. Okay, so and we can see that this is exactly the right term that we see in the second part of the questions. So, and then the question wants us to estimate the value for it. So we can directly plug this s equals to 0.1 into this term here, because since we know that x is smaller than 1, so the higher order terms are going to be omitted if we just want to estimate the value up to, say, 3 significant figure or 2 significant figure. Alright, so in this case here, we just substitute s equals to 0.1 into this expression here. So 2 plus 7 multiplied with 0.1 plus 10 multiplied with 0.1 square plus 7 multiplied with 0.1 cube, and we get a calculator and press, then we get 2.807. So, and I guess this is the right answer for this estimation here. So if you press a calculator to get the real expression for this, then here I can show my mathematical results, which is 2.8 2.80717. Alright, so the actual answer for this 1.9 times 10 to the power of time 1.9 times 1.05 to the power of 8 is actually approximately equals to what I calculated with Mathematica, which give 2.80717 2.80717, and then we can see that the estimation that we get by just plugging in s equals to 0.1 into this expression, which only up to x to the power of 3, is actually correct up to the third decimal place. Right. Alright, that's all.